period.
Hello, 8th period.
Oh, they're getting better.
One of the favorites.
They're getting better. Okay. So, section 2-3, extreme end behavior. I love teaching this section. It is hard to understand to start with, and then after you've got it, you're like, yes, I can do this, okay? So when we're talking about end behavior, we're talking about like as your function goes to the right, what is the y coordinates doing? As your function goes to the left, what's the y coordinates doing, okay? So they give us an example of 3 different graphs, right? 3 different graphs here, all right? This one is going up forever, and this one is going down forever. But at the same point in time, watch this graph. This graph, even though it's going up forever, he is still kind of going to the left forever. He will eventually go all the way out to the right forever. Right? He's going up faster than he's going out, but he will eventually touch all of the things to the right of himself, right? He'll touch all of those points because he'll keep going up and out that way, okay? In the same way, he will continue to go down forever, but he will continue to go to the left forever, right? Even though he's going down faster than he's going out, he's still going out this direction, right? So he will touch all of the x's going left and right. Does that make sense? He'll touch everything. So let's talk about end behavior. So on the end, as x goes to infinity, okay? Infinity is a really big positive number, right? Okay? So as x approaches infinity, infinity is to the right side of the number line, a big positive number. So this is kind of like saying as x goes to the right, okay? What is y doing as x goes to the right? What is the graph doing as it heads to the right? It's going up, right? Well, how do we say that it's going up? What's another way of saying that it's going
Infinity.
up? The y coordinates are going to infinity as well, right? So this guy is going to be infinity. Does that make sense? Yeah? Okay, now, as x is going to negative infinity, and negative infinity is like going this direction. So as my graph is going to the left, what is the y coordinates doing, or what is the graph doing as it heads toward the left of the graph? It's going down, and down means negative infinity. Does that make sense to you?
Yes.
Yes. That's it. That's basically what this lesson is, okay? So let's do the same thing for the middle one, all right? So he is going up and to the right and down and to the left. So as x goes to infinity, which means right again, as he's moving along the right side of the graph, as he's going toward the right, what is he doing? He's going up, so he is approaching infinity, okay? As the x is going to the left or going negative, right? As he's going to the left, what's he doing? He's going down, so he's going toward negative infinity. Does that make sense to you? Yes, it sure does. Beautiful, beautiful, okay? Last one, let's do this one. So he is going this direction, and is he going down forever and ever and ever?
No.
I think he's slightly going down forever and ever and ever, okay? It doesn't say that he really levels up, so I'm going to say that he is going down forever. Is he going down very fast? No, but he will eventually touch everything down below, even though he's not going down very fast, right? Okay? So as he is going to the right, as he is going toward infinity, what is he doing? He's going up or toward infinity also, right? As he is going to the left, what is he doing? He's going down, which is toward negative infinity, okay? So x's mean left and right, y's mean up and down, okay? So when they ask you for the end behavior on your homework assignment, end behavior, all you're going to do is you're going to start out by saying, hey, x is approaching infinity. Y is doing what? What's y doing, okay? As x is approaching negative infinity, what's y doing? Okay, you're going to put that for every end behavior problem, and then you're just going to determine what goes in that blank, right? So you're just going to talk about as x goes to the right, what's happening? As x goes to the left, what's happening? Does this make sense? Yeah? It's just using symbols for talking about right and left and up and down, okay? So as this graph right here in part A is going to the right, as we're going along the right side of the graph, to the right, my graph is going down, okay? Which means he is approaching negative infinity. He's approaching negative numbers that are big, right? Big negative numbers, okay? Now, as my graph is going to the left, because that's what negative infinity represents, left is negative infinity along the x. What's the y doing? He's going up, right? He's going up when he goes to the left. So he is going to positive infinity. That's going to be your answer for the end behavior. So you're going to have to write that out for each one of these and just fill in the blank for x and y. Okay, now they try to trick you on this one. Woo! They try to trick you on this one. So let's fill in our x approaches infinity, y approaches whatever. So as x is approaching infinity, meaning it's going to the right, what's y doing? As x approaches negative infinity, what's y doing? Okay? All right, so they try to trick you with this one because he's a horizontal line, right? Is he going up or down at all? No, he's staying at, what's that point that he's staying at?
4. 0, 4.
I think he's staying at like a coordinate of 4 all the way across, okay? So think about this in terms of left and right again. As x goes to infinity, which direction is that again? X goes to infinity is right. As he's going to the right, is he going up or down? No, he's staying at 4. That's the only time you will have a number in that slot, is if he's a horizontal line and staying there. Yeah? Okay, as x is going to negative infinity, which means he's going to the left, what's happening?
4.
He's staying at 4 again. This is the only time you will have a number in that spot, again, because he's a horizontal line, he's staying at that same point. Does that make sense? Okay. All right, let's do this again. Describe the end behavior of each nonlinear function. Oh, man. Okay, so these we had lines, but it's no different than when we have these functions right here. So again, we're going to do x approaches infinity, y approaches what? X approaches infinity, or negative infinity, negative infinity. Y approaches what? We're going to fill those blanks in, so we always start with that, and then we fill the blanks in. Okay. This is a little confusing.
Negative infinity.
For which one?
Both.
Jason says it's negative infinity for both of them. Okay? So as it's going to the right, as my graph is progressing to the right side, so as I'm going this direction, to the right along my graph, he is going down and down and down. He's going to do like this, right? He's going down, which means negative infinity. Okay? As I'm going to the left along this line right here, he is going also down, so also negative infinities. Okay? Good? Does that make sense? So it's basically saying on the right side of the graph, is he going up or down? On the left side of the graph, is he going up or down? He's going down on both, so it's negative infinity for both. Right? The more you do these, the easier it is to do, right? Like you can see that, right? Okay, so on this one. Now, notice that they're going opposite directions. Okay, they're opposite directions. So are we going to have like 2 negative infinities or 2 positive infinities? No, we're going to have one of each, right? They're both going opposite directions. So x approaches infinity. What's y doing? As x approaches negative infinity, what's y doing? Okay, so basically as the x is going to the right, what's happening? He's going down, he's going negative. As x is going to the left, what's he doing? Slowly but surely he is going up, right? So he's going to positive infinity. So that's another little trend that you can see, is that if they're going opposite directions, they're both going to be different negative infinity, positive infinity. They're not going to be one. You're going to have one of each, basically. One infinity, one positive, one negative infinity, one positive infinity. Versus here, you're ending both in the same direction, right? They're both going down on the ends, so they're both going to be negative. If you look like this, where he was a W facing upward, those would both be positive infinities. So on the right side, he's positive infinity. On the left side, he's positive infinity. Does that make sense? Yeah? Okay, perfect. Okay, now, these ones are pretty easy as well. We're talking about relative maximum and minimum. So if you're looking at a graph and you're talking about the maximum, you're talking about a high point, right? So this guy right here is considered to be a relative maximum. Now the reason why they call it relative is because, is he exactly the highest point along the entire graph? No, because on the right side here, he's going up forever, so he won't. There will be points on the left side. On the left side of this graph. If he continues to go up forever, there'll be points along here where he's higher than this guy. Okay, but they call him a relative max. Okay, a relative maximum. So in relation to the other points around him, he is at a hill. Right. The other one is a minimum. So a relative minimum. Okay, minimum. Now, is he the absolute lowest point on the graph?
No.
No, because there's other points down here on this graph that's going to be lower than he is, but relative to the points around him, he is at a valley, right? Okay, so that's why they call it a relative min, right? Good? All right, let's go to the back side. Now, you also have something called a turning point, okay? Turning points are just your maxes and mins. Max and mins. Okay, so you're looking for turning points. So this is a maximum. This is a minimum. All right, those are examples of maxes and mins. Why do they call this a turning point, do you think? Why do they call that point up there a turning point? It was where it turns around and goes the opposite direction, right? On one side it's going up, and then it turns around and goes back down, right? Over on the right side, in the minimum here, he's going down, and then he turns around and he goes back up again, right? It's turning around. It's going the opposite direction. That's why they call it a turning point. So those are your maximums and minimums, okay? And they also will sometimes label these as extrema, okay? What word do you hear in the word extrema? Extreme, like maxes and mins, those are extreme points. Like highs and lows, extreme points. So extrema, those mean the same thing. Turning points are your extrema, okay? All right, so let's talk about extrema on the graph, okay? They only give us a table here. So the graph and the table below are functions with extrema. These two are not related. Not related, I don't think. Nope, not related. Not related. Like this table is not graphed in this function. Does that make sense? Those two are unrelated to each other, right? Not related. So the table and the graph below are functions with extrema. Estimate the zeros. Okay, estimate the zeros. And then estimate the coordinates at which the relative max and min occur. Okay. Zeros. A zero is the place where y is equal to 0. We're going to estimate where y is equal to 0. Okay? So we need two things. We need zeros, and then we need maxes and mins. Okay? We need zeros and we need maximums and minimums. Okay? So places where y equals 0. I'm going to zoom in on this table right here. Places where y is equal to 0. Okay? The y coordinate is the right side of the table. Okay? Does he touch 0 exactly anywhere along that table? No. What? The y coordinate has to be equal to 0. But if you look, here it's at positive 3, and then he bumps down at 1 and he goes toward negative 2. Does that make sense? So 0 lives in between these 2 points, right? So that means he has to cross, or he has to cross at a place between 0 and 1. Does that make sense? So maybe it's 0.5. We don't know if it's necessarily 0.5, but we do know it has to be between those 2 points. I'll show you what that looks like, okay? So if you don't believe me, here's the graph. Let's say we had 0, 3. That's that dot. And then at 1, we're at negative 2, right? 1 is over here at negative 2. So if I have a line connecting those two, right? This is the point 0, 3. This is the point 1, negative 2. At some point between 0 and 1, he had to have crossed the x-axis. Does that make sense? Okay? So some point between 0 and 1, he had to cross. Do I know that it's exactly at 0.5? Not necessarily. It could be at 0.1 instead. So what I'm going to say is I'm going to say that my zeros are located between 0 and 1. So I have a 0 that's located between 0 and 1. Okay? Now, there is another one on this graph. Where else is he going to have a 0? Okay? Look at the second place where y is going to be 0 at. You see another place where y is 0? Between negative 1 and 42. So he's down all the way down here at negative 1, and then he has to go all the way up to 42, which is somewhere going to cross that y-axis, right? So where is my 0 going to be between? On the x-axis. I'm going to have a 0 between what? Nope. Between 2 and 3, right? 2 and 3 on the x-axis, I'm going to have a place where y is 0. Does that make sense? So where on the x-axis will I have places where y is 0? Between 0 and 1, y is going to be 0, and between 2 and 3, y is somewhere going to be 0. Does that make sense? If he's down here and he goes all the way up here, he's got to cross at some point. If he's up here and then he's down here, he's got to cross at some point between those two, okay? Does that make sense? Is that hard? Okay? All right, now let's talk about maxes and mins for just a second. So according to this, let's talk about high points, right? So what the graph is doing is he's up here at 7, he goes to 2, then he goes up to 3 and then down to negative 2. Okay? So did we hit a high or a low point there in that little range?
Yeah.
Well, 7, since he's on the end of the graph, he could end up going on forever in one direction, right? So we don't necessarily know that he's a maximum. But if he goes from 7, down to 2, up to 3, and then down to -2, isn't that what it's doing, right? 3 is going to be a maximum. So I might have a max at 0, 3. Does that make sense? I'm going to say I have a maximum at 0, 3. Okay? Now, do we have a minimum somewhere? So he's up here at 3. He goes down to -2 and then -1, which means I go from there, I go up to -1 and then up to 42, right? So do I have a minimum somewhere?
Yes.
Where? Something -2, right? 1, -2. 1, -2 is -2. 1, -2 is where my minimum is located, right? Is a low point. So just think about what that graph is doing. Like he's high and then he goes low and then he goes back high again. Well, that means he's going to have a low point, right? So think about what that graph is doing. Now, when you have like it actually graphed, it might be a little bit easier to determine those two things. So zeros. Zeros are where he crosses the x-axis, okay? So here's the x-axis right here. How many places is he crossing? 2. He's crossing at 2 places, okay? Now, he's crossing between where and where? Between 0 and 1, right? That's this point right here. That's between 0 and 1. Okay, and then where else is he crossing? It looks like he's crossing on exactly 2. Exactly at 2 on the x-axis. Does that make sense? Those are places where he's crossing. Okay, did I get all of them then? Yep. Now let's do some maxes and some mins. Max and mins. Mins. Okay, so let's do some maxes. Do I have a maximum point? This is right here. I gotta outline that. Where is that point located, approximately? This is my maximum point, right? Okay. Let's say he's like negative what? Negative 0.5 maybe, not quite 0.5, and then where is he at elsewhere? 3.2? Sure, something like that. We'll just guesstimate. These are all going to be guesstimations. Okay, maxes are at negative 0.5, 3.2. Okay, is that all the maximums that I have? Yes. Minimums. How many minimums do I have? That one way down there. And do I have another minimum?
No.
Yes, I have one here and one here, right? Okay, so let's do the very, very bottom one first. Whereabouts is he located? What would you say? How much did you go over? 1.5, sure. Let's go over 1.5 and down to, we want to go down to -4? Down to -4, okay? And then also, we have a minimum at, where else would you guesstimate where he's at? -1.5, sure, comma?
1.75.
Sure, 1.75, we'll go with it. Okay, these are just guesstimations, so you're just trying to guesstimate where those maxes and mins and zeros are located, yeah? Okay, guesstimating where approximately they are, okay? All right, next, last example. The cost of an orange changes over the course of a year. Did you know that? Like the cost of strawberries. If it's not strawberry season, then they're like really expensive. They're like $5 for one of those little cartons. But then my kids are like, but Mom, we need strawberries. No, we don't need them that bad right now because they're really expensive right now. We don't need them that bad. So we have to go find a different fruit that's in season, right? Oranges, if it's not during like primary orange harvest season. I don't know. Well, let's find out. Month. Oh, the cost is highest on month 3. So it's not March.
Best in 10.
It's best in 10, which is October. So it must be orange harvest season in October.
Oh my gosh,
Oh my gosh. So get your oranges. Get your oranges in October. Get your oranges in October because they're cheapest. Okay? All right, use the table and graph to estimate the extrema for this function. Oh my gosh. Holy cow. Okay, so maxes and mins. Let's talk about maxes and mins. Max and min. We're almost done. Where are the maximum months? Let's just list the months out. Okay, where is the highest price relative? Okay, the highest relative price where we don't want to buy. March and 5, which is May, right? These 2 months, 3 and 5, we do not want to buy oranges. March and May. No, that's bad. Okay, when do we want to buy? October. Now, if you're really starving for oranges, like in the months of March and May, you might as well buy some here in April because it does kind of dip a little bit. But I'm not going to put that down as a minimum because we definitely really for sure want to buy in October, right? Definitely for sure. Stock up in October. If only oranges would last until March, right? Dang it. My kids are addicted to like the little cuties. They don't know that they're oranges. They just call them little cuties. You know, little cuties, little tiny oranges. Whatever. Okay. So is that all the way I had to do? Explain the extrema in the context of this situation. We already kind of did that by converting the 3s and 5s to their specific month, right? It's really expensive in March and May, so that must be when orange harvest season is not in its prime, right? Orange harvest season is in October. That's when we want to buy oranges. Okay, that's when most of them are coming out. Okay, good? That's all I have. A lot of this is going to be guesstimation, like trying to find guesses on the graph of where they cross and then that type of thing. Okay.